notice, and this is the typical copyright. We continue with mathematics syllabus, CSEC, 2018 to 2027 syllabus. I emphasize once again that it is crucial that you know the multiplication table, the times tables, which is this one. And of course, you do need to get one or two good math textbooks for CXC. These are the ones recommended by CSEC in its syllabus. This one on the right and this one on the left. This one is volume 1, and there is also a volume 2. Disclaimer. Schedule of videos. In September 2024, that is this month, I am hoping to have all 32 videos from section 1, number theory and computation, published. Then next month, October, the 15 or so videos on consumer arithmetic, and so on. November, sets. December, that is by the end of the year, measurement. And then in January 2025, statistics, followed by algebra in February, relations, functions, and graphs in March, and then geometry and trigonometry in April 2025, and finally in May, hopefully by mid-May, vectors and matrices. Just a reminder that I have divided section 1 into 32 videos, all of which will be made available on YouTube in their entirety, the whole videos. This section forms the foundation on which the rest of the syllabus is based. How well you can handle this section, section 1, will predict how well you will be able to do with the rest of the syllabus. And again, these 32 videos from section 1 cover the math schoolwork up to the end of Form 5 or grade 9 in secondary school. That is from Form 1 to Form 3. So we are here, video 14, factors and multiples of integers. Now, we did something like this before, way back here in video 3, when we were talking about factors and multiples. So we know some of this already. Of course, we have to go to video 32 for this section, so we still have some way to go. Objective 5, list the set of factors and multiples of a given integer. So we will be looking at positive and negative factors of an integer, and we will also be looking at positive multiples. Well, negative 2. And what you see up here is a print screen from the current syllabus. There are only limited factors for a number, but when you talk about multiples, that's infinite, as many as you want, unless a range is specified. So we only need one video for this objective, but we will divide it into 2 parts. In part 1, we will talk about multiples of integers, and in part 2, we will talk about factors of integers, including negative factors. Recall, in section 1.1, part 1, when we were talking about sets of numbers, that's the very first video, we mentioned natural numbers, and that will be the counting numbers 1, 2, 3, and so on. like this. Then we talked about whole numbers, which would include 0. So the whole numbers will include 0 as well as the natural numbers. And then we talked about integers, which would be the negative whole numbers plus 0 plus the positive counting numbers, which would be this. And so this objective is saying that you need to say what the set of factors are of a given integer. In other words, any positive or negative whole number, 0 doesn't really count in this case. Integers, as we learned, are the set consisting of the positive and negative whole numbers and a 0. And it is given the symbol Z, which would be -2, -1, 0, 1, 2, and so on. And that is from your syllabus. So as we said, factors are finite, limited, whereas multiples are infinite unless a range is specified. So part 1, multiples of integers. That is what we are doing now. And then later on, we will do part 2. So from video 1.1 part 3, when we were dealing with factors and multiples, we said that factors of a whole number are those numbers by which it can be divided without a remainder. And then we talked about multiples, the product of multiplying a number by a whole number. For example, multiples of 5 are 10, 15, 20, or any number that can be evenly divided by 5. And we said we need to modify that definition from your syllabus and exclude 0 and 1. So a multiple is the product of multiplying a number by a whole number, excluding 0 or 1. So now we are going to deal with multiples. Multiples of integers. If you multiply one number by a whole number, excluding 0 and 1, note that, the answer is a multiple of the first number. For example, if you multiply 5 by 3 and you get 15, then 15 is a multiple of 5. That is to say, in 15, you can find 3 5s, 5 plus 5 plus 5. So you have a multiple of 5s in 15. If you multiply 5 by 4 and you get 20, then 20 is a multiple of 5. Again, in 20, you could find 4 5s, 5 plus 5 plus 5 plus 5. So you have a multiple of 5s. -5 multiplied by 5, you get -25. -25 is a multiple of -5. That is to say, this -5. In -25, you can find several -5. As a matter of fact, 5 of them, as you see here. An example 4, -3 multiplied by 6 is equal to -18. -18 is a multiple of -3. That is to say, in -18, you could find a number of -3, to be specific, 6 of them as shown here. So -18 is a multiple of -3. While a number has a limited number of factors, we said that before, there is no limit as to the number of multiples a number can have. So if you multiply a number by a whole number, just repeating, excluding the 0 and 1, the answer is a multiple of the first number. We already said that while a number has a limited number of factors, there is no limit as to the number of multiples a number can have unless a range is specified. So, state the multiples of 6 up to 40. Well, we did say that 6 itself doesn't count because you can't multiply 6 by 1. You only have one 6 there, not a multiplicity of 6s. And so in 12, at least you have two 6s, 12, 18, 24, 30, and 36. Example 2, state all the multiples of 4 up to 30. Again, we will leave out 4, and we begin from 8, 12, 16. In 16, you could find 4 4s, 20, 24, and 28, and we will stop there because we can't go beyond 30. State all the multiples of 3 from 25 to 40. Well, the first multiple of 3 beyond 25 is 27, and then 30, 33, 36, 39, we have to stop at 40. And finally, what are the multiples of negative 3 from negative 10 to positive 7? Well, we know that negative 9 is 1. We know that negative 6 is 1. We know that negative 3 itself doesn't count. We know that 0 doesn't count. So we are excluding multiplying by 0 and 1. Question is, somebody may wonder about positive 6. And the answer to that is no. You can't find a negative 3 in a positive 6. So multiples, the product of multiplying a number by a whole number. And the example CXC gave is this one here of 5. And as we said, 0 and 5 are left out. So we modify CXC's definition and add to it excluding 0 and 1. So let's look at this multiplication table that you need to know if you don't know it already. We will leave out these two, that row there and this column here, because those are multiples of 1. Now, if we take this row on the top here and we use that to multiply the one on the left here, this one would always be positive, because remember we said we are multiplying by a whole number excluding 0 and 1. So that will be positive 2, positive plus 3, plus 4, and so on. However, if what we are multiplying on the left here, this one could be negative or positive. Take, for example, this 7 here. If we multiply that 7 by this 6 here, we will get 42, which is a positive 42. But we can also take a negative 7 and multiply it by that 6 up there, and then we get a negative 42. That is what we mean by multiple. Multiples, we need to move from multiples and go to factors, but one last thing. 7 multiplied by 0, 0 is not a multiple of 7. 7 multiplied by 1, we only can find 1 7 in that 7. So obviously, it's not a multiple either. Now, in the case of 14, you can find 2 7 in that 14. So at least you have 2 7s. So 14 would be a multiple of 7, and so on. Negative 7 multiplied by 3, you get negative 21. So you have 3 negative 7 in negative 21. So negative 21 is a multiple of negative 7. And the same argument holds for 7 times 4, 28. All right, I think that should suffice for multiples. We need to move on to factors. If you find this video useful and interesting, please like and share. That is to say, like and share. And you may even consider subscribing to this channel. As I said before, it doesn't cost you anything, and it means a lot to me. So we go on. We are now going to deal with factors of integers. So we already talked about what multiples are, and we corrected CXC definition. Now for factors. The factors of a whole number are those numbers by which it can be divided without leaving a remainder. So if you have a number and you can divide it by another number which generally is smaller or the same number without a remainder, then that number that you divide it by is a factor of the original number. And we have factors are finite. It includes 1 and itself. So here are the prime numbers from 1 to 100. We begin with 2, 3, 5, 7, and so on, 89, 97. We already know that each prime number, by definition, has only two numbers by which it can be divided without a remainder, itself and 1. So prime numbers have only two factors. There are only two numbers, either equal to that number or smaller, that can divide it without a remainder. Now let's take any number that is not a prime number and start to divide successively by the lowest prime number, then the next higher one, and so on, ensuring that each time there is no remainder. So if we take 30, we divide it by 2, that's the first prime number, we get 15. We can't continue dividing 15 by 2, so we divide 15 by the next higher prime number, we get 5. Well, we can't divide 5 by 3, so we divide 5 by 5. That's the next higher prime number. In each case, we don't get a remainder. Now, each of those divisors is called a prime factor of 30. If we multiply them, we will get back 30. That is to say, 2 times 3 times 5 will give us 30. Remember, those are the prime factors only. Now let's set up that division that we just did slightly differently, like we are finding LCM. 30 divided by 2, we get 15. 15 divided by 3, we get 5. 5 divided by 5, we get 1. So we can see the prime factors on this left-hand side here are 2, 3, and 5. Of course, 6 and 10 are also factors of 30, but they are composite numbers themselves. Normally, we only look for the prime factors of these numbers. If the prime factor appears more than once, it will only be mentioned once. So in the case of 40, we divide by 2, we get 20. We divide that 20 by 2 again, we get 10. We divide that 10 by 2 again, we get 5. And then finally, we divide that 5 by 5 and we get 1. Notice that even though we divided by 2 3 times, we will only list it as one prime factor of 40. So the prime factors of 40 are 2 and 5. Another example, if we take 70 and we divide by 2, we get 35. We divide by 5, we get 7. We divide by 7, we get 1. These numbers, these divisors on the left here, are the prime factors. And if you see a factor appearing more than once, you would only list it once. So the prime factors of 70 are 2, 5, and 7. Now let's take another example, 100. If we divide 100 by 2, we get 50. We divide that 50 by 2, we get 25. We divide that 25 by 5, we get 5. Divide that 5 by this 5 here, we get 1. So these numbers on the left here are the prime factors of 100. But because 2 appears twice, we will only list it once. And 5 appears twice, we will only list it once. So the prime factors of 100 are 2 and 5. Now, in the next video, we may have to list the 2 and the 2 and the 5 and the 5. List all the prime factors. But for now, 2 and 5 will suffice. But note that all the factors of 100 are 1, 2, 4, 5, 10, 20, 25, 50, 100. Each one of those can divide 100 without a remainder. As I said, depending on the situation, you may have to actually list all the prime factors, like 2 and 2 and 5 and 5, depending on what you are doing. So the set of factors of 100, the set of factors, all factors of 100, would be this. The set of prime factors of 100 would be that, 2 and 5. And the pairs of factors of 100 are, that is to say, which two factors can you multiply and get back 100? So 1 and 100, 2 and 50, 4 and 25, 5 and 20, and then we have that lone 10 there. We will double it up, 10 by 10, you will get back 100. Let's look at another example. Let's take 40 this time. If you divide 40 by 2, you get 20. Divide 20 by 2, you get 10. Divide 10 by 2, you get 5. Divide 5 by 5, you get 1. So the prime factors of 40 are 2 and 5. Remember, I said there may come a situation where you have to list that 2 3 times. All the prime factors of 40 are 2, 2, 2, and 5. Depending on the situation, you may have to list all of them like that. But note that all the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. In other words, these numbers can divide 40 without a remainder, and they are either equal to or less than 40 itself. So the set of factors of 40 are these 1, 2, 4, 5, 8, 10, and 20, as you saw up here. And the pairs of factors of 40 are 1 and 40. If you multiply those two, you will get back 40. 2 and 20, 4 and 10, and 5 and 8. Multiply those two, you will get back 40. Now let's consider the factors of negative 100, because we were dealing with positive integers all along the line. So if you look at negative 100, notice that we get these factors. Well, we need to understand that all those positive factors that we listed as factors for positive 100, we can list them as negative factors for negative 100. But then we need to understand that negative 100 also has positive factors. So twice as many as its positive counterpart. So negative 100 has these as factors, and it also has these as factors. And these would be the prime factors of a negative 100. So bear that in mind. How much of this do you understand? And remember, 4 is a factor of 12. Is that true or false? That is true. Negative 3 is a factor of 6. That is false. You can't have a negative factor of a positive number. Negative 8 is a multiple of negative 4. That is true. You could multiply the negative 4 by 2. 8 is a factor of 24. Now this one is true, unlike that one. You can have a positive factor of a negative number, but you can't have a negative factor of a positive number. So this is true. 15 is a multiple of negative 5. That is false. 4 is a multiple of 12. Remember, multiple will be bigger than the number itself because you're multiplying by at least 2. So this 4 here is not correct. That is false. Negative 4 is a multiple of 4. That is false on 2 counts. 2 and 5 are prime factors of 10. That is true. 4 is not a prime factor of 8. That is also true, because 4 is a composite number. So, objective 5, list the set of factors and multiples of a given integer. And that's it for this objective in section 1.